How are we today? Wonderful. I'm hoping you're great. So today we're going to look at the different types of conditional statements that can be made up. Conditional just means that if something happens, then something's going to happen as a result of that happening. That makes almost zero sense, huh? So if I said something happens, like if my car broke down, then I need to get it fixed, right? There's a causation kind of thing happening. If well, let's look here. If you can see the stars, then it is night. So these are like conditional statements. Now we have different types of conditional statements. We have our original conditional statement, which is right here. If you can see the stars, then it's night. Let's just identify the parts real quick. So you can see the stars, that's the hypothesis. The conclusion is it is night. So what I'm saying is you can see the stars, therefore it has to be night. Now, this is the original conditional statement, therefore it would be written as P implies Q. P being the hypothesis, Q being the conclusion. So this little arrow means implies. And this is just logical notation, meaning that's the notation that we would use so that we don't have to write this garbage out every time. Because, you know, it gets really redundant, and as math people, I don't want to write a whole lot. So P implies Q means H implies C. Or if you can see the stars, then it is night. Okay? So this is our conditional statement. Now I want to talk about the different ones that we have. The first one is the converse. Now the converse is the notation Q implies P. So that what that means is I'm just basically taking my conclusion and I'm placing it where the hypothesis was, and I'm taking the hypothesis and putting it where the conclusion is. So like this. Instead of if you can see the stars, then it is night, you would say if it is night, then you can see the stars. So the converse would be if it is night, then I can see the stars. If I said you could say you can say I, it doesn't matter. But I'm basically not changing anything about it. So if it is night, then I can see the stars. I'm just replacing those. I'm keeping if and then where they're located right now. All right, the next one I want to talk about is the inverse. Okay, the inverse is not P implies not Q. So in other words, you see this little notation, this little tilde on the outside, that means not. It means negating it. It means to change it from being what it was to what it's not. So for example, if I said something like, if it is night, I could say it's not night now, right? I don't have to say day. I could just say it's not night. So what this would look like is, it would look like if you can see the stars, then it is night, but we have to negate it. So this would be if you can't see the stars, then it is not night. And that kind of makes sense. I mean, negating, okay? So this little tilde thing, just remember that means not. It means to negate. I don't want to say not too many times, because whenever I think about it, I think about it being just the opposite of what it was. So if I started with saying you can't see the stars, then I would have to say you can see the stars, not making it a negation. It's just changing that thing. Okay, changing it so that it's not, it's the exact opposite of what it's saying. The last one is the contrapositive. And that one is not Q implies not P. So in other words, I'm taking the converse of the inverse. The converse of the inverse. That means that I'm going to take the inverse and just switch the spots of the conclusion and the hypothesis. So it will be read, if it is not night, then you can't see the stars. You cannot see the stars. So if it is not night, then you cannot see the stars, or you can't see the stars. Now, each one of these statements has their own truth value, okay? If they are all true, which we'll talk about in a little while, if they are all true, then the whole statement is true, and therefore it's known as a definition, okay? So if all of these statements are true, then that makes they're all going to be true, and that makes the original statement true, and therefore everything is true. So that makes it a definition. Sometimes when we flip-flop these things around, they make them false. It may have been true in the beginning with the original conditional statement, but whenever I change it and make it a converse or an inverse or a contrapositive, it may make the logic false. It may not make any sense. And that's okay. It can be false. And when things are false, we have to provide counterexamples for them. Okay, so let's just review real quick. So the original statement that we are given is P implies Q, okay? And that's what this means. P implies Q. P being the hypothesis, C being the conclusion. You're probably like, well, why the heck don't we just use H and C? Well, because when logic, there's like a whole different thing, not just geometry, but a whole different math. It's just logic. And in logic notation, they use P, Q, and R. And so those things have to be used the same way. And so we can't just use H and C. So P implies Q is the original statement. The converse is Q implies P. That's flipping them. Okay? We're not changing the if and the then. We're just changing the stuff that's after it. We're moving it. Okay? The inverse is to negate that. Okay? To make it the opposite of what it was. So if it said it is night, that means it's not night. Okay? Things like that. So if you can't see the stars, then it is not night. Contrapositive is the actual negation of the converse. So I'm just taking the converse and negating it. So we're taking that original converse statement and just making it the opposite of what it was. So since if it is night, it's not night. So that's all we're doing here, and that's just writing all the different statements, okay? And those are called conditional statements. Toodaloo.